Hello everyone. So today we will learn how to calculate the molar solubility if we are given the Ksp value of any ionic compound, right? So in this problem the ionic compound is lead 2 chloride and we are given its Ksp value at 298 kelvins and we have to calculate its molar solubility. It means that we have to find like how many number of moles can be dissolved in 1 liter of water so that it forms a saturated solution, right? Okay, let us assume that the molar solubility of lead 2 chloride is x moles per liter, right? Let us say this is x moles per liter. Okay, so first of all, let us try to write the dissolution equation of lead 2 chloride, right? As the name suggests, so the lead is in the 2 positive oxidation state because we have these two Romans, right, in the brackets. This tells us that the lead is in the +2 oxidation state. So based on that, the formula of lead chloride would be PbCl2, right? So PbCl2 in the solid form, and it establishes an equilibrium with its ions, and the ions involved in PbCl2 are lead 2 positive ion in the aqueous form, and chloride ion in the aqueous form, right? Okay, as you guys can clearly see that one molecule of PbCl2 generates one ion of Pb2 positive and two ions of Cl negative, right? So two ions of Cl negative, and which also tells us that if we are dissolving x moles of PbCl2 in water, right, and they're going to produce x moles of Pb2 positive ions and 2x moles of Cl negative ions. Okay, let us try to use this information to write the ice table. Okay, I'm going to write ice table underneath this chemical equation. So initial concentration represented with I, the change with C, and the equilibrium concentration with E, right? Okay, so the first row is for the initial concentration, and we know that initially at the initial stage no molecule of PbCl2 is dissolved, so no ions of Pb2 positive and Cl negative will be present in the solution, so they are both 0 and 0. And we do not need to write anything underneath PbCl2 because the PbCl2 is present in the pure solid form, right? And as we know that we do not include the pure solids and liquids in the expressions of Ksp, right? Okay, and as we discussed earlier, if x moles of PbCl2 dissolve in water, right, to reach the saturation, to reach the point of saturation, the x moles of Pb2 positive will be formed and 2 x moles of Cl negative will be formed. Okay, as I said, these moles of ions will be formed, right? So we're going to write positive sign here because they are being formed, right? And if something dissociates, we write negative here, as we used to write like negative x or negative something here on the reactant side, right? Okay. After that, we need to write the equilibrium concentrations, and which we can write simply by adding these concentrations, right? Which is 0 plus x is simply x, and 0 plus 2x is 2x, right? Okay. Now the next step. In the next step, let us try to write the expression for Ksp using this dissolution equation. So Ksp is given by the product concentration, which is in this case Pb2 positive concentration raised to the power its stoichiometry coefficient, which is just 1, so 1 here, and the concentration of chloride ions raised to the power its stoichiometry coefficient, which is 2, right? And we are given the value of Ksp, which is 1.70 times 10 to the minus 5. Let us plug in the value of Ksp and the equilibrium concentrations into in here in the equation and try to solve for x, right? So Ksp is 1.70 times 10 to the minus 5, which is equal to x, right? And this is 2x whole square. Now let us solve this equation for x and simplify the right hand side first. So this which implies that 1.70 times 10 to the minus 5 is equal to x times 4x square, right? Let's multiply these two, which will give us 4x cube, right? And the left hand side remains the same. Now we're going to get rid of this 4. We want to get rid of this 4 so that we can divide both sides by 4. Let's divide both sides by 4 so that we can get rid of this 4. So now this cancels, this 4 cancels this 4, and we have only x cube on the right hand side, which gives us this gives us 4.25 times 10 to the minus 6, which is equal to x cube, right? Now we want the value of only x, not x cube, right? So in order to get rid of this cube, let us just take cube root on both sides so that we get the value of x. This gives us x equals to 1.62 times 10 to the minus 3 moles per liter. And I'm deliberately writing the correct number of significants here, right? But if you take the cube root of this number in your calculator, you will find the more number of decimal places, right, in your calculator. But I'm writing only 3 significant figures just because if you look at the data given in the problem, which is the value of KSP, has 3 significant figures, right? So that's why I'm writing 3 significant figures here, right? Therefore, the molar solubility, the molar solubility of PbCl2 is 1.62 times 10 to the minus 3 moles per liter at 298 Kelvin, which means that if at 25 degrees Celsius or 298 Kelvin, if you dissolve more than these many moles, then the PbCl2 will precipitate out, right? So if you dissolve these many number of moles at this 298 kelvins, so this is going to form a saturated solution, right, which is the molar solubility. Okay, I hope you guys have got the concept and understood everything that I tried to solve here. And if you guys have any questions, you guys can write in the comment sections below, and I'll try my best to address most of the questions. Thank you very much. I'll see you in the next video. Bye bye. Take care.